There is a small area in my house. I have no way to pull a PoE cable to the ceiling. What you see now is what I measured using Wi-Fi Man before I install any access point. You can see the orange part will have very bad Wi-Fi signals. I tried to install a regular round access point on the wall, but it didn't achieve good effect. Thanks to Ubiquiti for sending me this U7 in-wall access point to check out. It is surprisingly tiny and comes with a very sturdy metal wall mount plate. Just for a size comparison, the middle one is the U6 in-wall. As you can see, it's just slightly larger than my palm. It's very cute. The right side one is also an in-wall access point, U6 Enterprise. You can see this U7 in-wall is much smaller than it. And the left one, round shape, U7 Pro Max, is also much bigger in every single dimension. After installing it on the wall in that area I mentioned previously, you can see the right side new measurement is much better than the left side. The whole area is showing green color. To understand the differences between in-wall access point and on-ceiling access point, we can check the AP antenna radiation patterns provided by Ubiquiti. For example, here we can compare this U7 in-wall with the traditional U7 Lite. So you can see 4 graphics here. The first one is for 2.4 GHz. So for this Wi-Fi band, the patterns are not really very different. But when the frequencies are increased for 5 GHz, the low, middle, high frequencies for 5 GHz, you can see the patterns are dramatically different. And for the in-wall access point, you can see in the middle where the face of the access point is facing has the strongest signal, and the area which is at the same level of the surface of the access point, which means if you mount it on the wall, that means close to the wall area, the signal is the weakest. But if you check the U7 Lite, you can see the area is pretty even. So the access point guarantees it covers the whole area if you mount it on the ceiling. But if you mount this type of on-ceiling access point in the wall, you will waste a lot of antenna power in the area which is not really needed, the area which is close to the wall. So for the real area you want to cover, you can see U7 Lite is not really focusing its energy to the middle area. If you force to install a on-ceiling access point in the wall, you may not achieve good coverage. And for this U7 in-wall, according to this store page, it's designed for hospitality environments. You can imagine if you hide this access point under the desk on the wall in a hotel room, it will provide the coverage to the room, and thanks to its tiny size and installation position, it may not be easily noticed. Now let's address the elephant in the room, Wi-Fi 7, because Ubiquiti categorized this U7 in-wall as one of its Wi-Fi 7 access points. But if you go to the setting for this access point, you can only find 2.4 GHz and 5 GHz Wi-Fi bands. You don't see 6 GHz. Many people think Wi-Fi 7 equals to 6 GHz. It's not really the case because, for example, for 5 GHz, the channel width, the widest one is 240. This is Wi-Fi 7. And then there's another thing about Wi-Fi 7 is about the max QAM, which is the method to encode data when transferring data on the air. Because of the enhancement of QAM in Wi-Fi 7 in the same frequency, the AP can carry more data, more information. But that's not something you can configure in the settings. And another major change in Wi-Fi 7 is MLO. Yes, even for this tiny U7-IW, MLO is supported. You can see I already set up this testing SSID. It only broadcasts using this U7-IW. For Wi-Fi band, I select the two Wi-Fi bands, then I enabled MLO. In the left side, I do have a Windows machine. It has a Wi-Fi 7 card, so I can use it to validate the MLO. If I go to the Wi-Fi connection details in the Windows machine, you can see the protocol. It is Wi-Fi 7. See the network band. It lists both Wi-Fi bands. About the link speed, looks pretty good. From the UniFi network controller, if I go to client devices, for the client details for this Windows machine, you can see both 5 GHz and 2.4 GHz are listed, but only the 5 GHz is showing the rates, which means the MLO support for this access point to work with this particular client is the SR mode. It can use only one single radio at each time. So currently the 5G is better, so the MLO chooses 5G to do the data transferring. So we can test the current speed by using a iPerf3 server in the left side terminal. Then in the Windows machine, let me run the iPerf3 testing. By default, it will test sending or uploading. Okay, you can see for one single connection, the speed is already very good, more than 1.5 gigabits per second. Then let me try to increase the parallel connections to 10. Let's see whether we can get even better throughput. Yes, it's slightly better, about 1.8 gigabit per second. Okay, very good. Now you see why this access point claims to be a Wi-Fi 7 access point. Let me do a more general testing. In the lower part of the screen, I'm going to use 4 Mac machines, one client connected using 2.4 GHz, the other 3 connected with 5 GHz. By the way, all the 4 Mac clients, they don't support Wi-Fi 7. I simply want to see during heavy parallel loads from multiple clients how the AP will behave. If you check the specification for this AP, you can see for 5 GHz and 2.4 GHz, the total data rate is about 5 GB per second. And on the other hand, this AP, it has a 2.5 GBE uplink. Theoretically, the total throughput from the uplink part perspective should be 2.4 GBE per direction. Then let's see in real world, by using these 4 clients, by connecting to a server running in the LAN part, let's see what's the total throughput I can achieve. I'm running the 4 iPerf3 servers from the same machine, so I need to run them by using different ports. So the first one, listening to 5201, the next 5202, third one, fourth one. Then for all the 4 Mac clients, I already show you their current Wi-Fi connection status and their respective speed. But as I mentioned, their individual speed doesn't really matter. What I really care is the aggregated speed. So then from the first client, which is 2.4 GHz, run iPerf3 client by using 10 parallel connections. Okay, it's about 100 megabit normal for 2.4 GHz. Then for the second client, okay, about several hundred megabit per second. Third one, okay, this one is faster. It's about 1 gigabit per second. The last one, okay, this one is slower because of the interference on the air, right? From the UniFi network controller, from the port monitoring, we can see the activity. You can see this is something I complained in other videos as well. This information is not refreshed frequently enough, but at least you can see now from the AP perspective, the TX rate is about 1.5 GB per second. Apparently, it's higher than GBE, which means the 2.5 GB part makes sense. If, like previous generation, is only using GBE part, it will be a waste of the capacity of the access point, right? Because this is just a tiny access point. Of course, I don't expect it to have super performance. The current one is good enough for me or for its use case. Then let me move on to the 2 additional ports on the AP. This is the port overview for this access point. Even though it's an AP, it has a switch-like port view. It has 2 extra ports. They are both 2.5 GBE. Even though there are only 2 additional ports, there are several interesting things we need to discuss. Let me go through them one by one. First, so the port 1 is not PoE. I already connected to a computer. If I click on it, see, even though it does have the regular VLAN setting UI, they are grayed out. So from this tooltip, you can see I need to enable the port VLAN option. So for the extra ports on the involve AP to utilize VLAN related settings, you have to go to the access point, go to settings, scroll to the end. See here, there's a port VLAN configuration. This setting doesn't exist for regular AP, only for the involve access points which have extra ports. You have this option. So I need to enable it, apply changes, then go back to the port overview. See now, if I try to set VLAN again, they are enabled. So that's the first thing I want to mention. The second thing is about the port 2. For the port 2, the name is PoE out plus data. And I already connected a UniFi small switch, which is supposed to be powered by PoE in, but this part is still showing gray color. The reason is, see this column, PoE mode is off. So you may wonder why it's off. The reason is this is not a full-featured PoE port. It is a pass-through port. If I click on it, see the PoE setting is off, and if I enable the pass-through, see the warning? Because this kind of pass-through PoE port is not smart enough. If you enable it, it will provide power. But for regular better PoE ports, if you will, they will decide whether the device really needs PoE or not. Only when it's needed, it will provide power. But for this kind of dumb pass-through part, if the other side is not a PoE device, if you enable the PoE, it may destroy your device. So you need to be careful. That's why this part, by default, the PoE is disabled. But because I'm sure the device I plug in is a PoE powered switch, I will proceed, apply changes, then give it some time. You will see the switch is connected. See, the connection is established and the device is USW flex 2.5 GHz. So now I have utilized both ports. One PoE, one is not. Now I'm good with the PoE functionality. An interesting testing I'm going to do is, you can see I already resumed the 4 iPerf3 testing sessions, and you can see now this time TX rate is about 1.55 GB. So we still have about 1 GB capacity for the TX direction, and for the RX it's barely utilized. So now, because we have this Windows machine connected to this 2.5 GBE port, let me use this Windows machine as a iPerf3 client, and let's see whether I can saturate the throughput for this uplink port. In the brand new iPerf3 server file, let me run a new session of iPerf3 server. Then from the Windows machine, I already disconnected its Wi-Fi, so the coming iPerf3 testing will be done through Ethernet port. So the way I'm going to run iPerf3 client is by using 10 parallel connections, connecting to the 5205 port, and this time I want to run it in bi-direction mode. Remember, I want to saturate both directions, right? Let me run it. The result is a little bit disappointing for the part 1's testing. From the TX rate, we can see it's almost 2.5 GB, right? I'm good because what we see now is the total throughput for the 4 Wi-Fi clients and this Ethernet client, right? But for the RX rate, this is completely from the Windows machine. You can see the speed is not too good. I am not sure why for the Ethernet throughput it's not as good as I expected. To exclude the factor of the 4 Wi-Fi clients, let me stop those 4 Wi-Fi clients. Okay, then let me test the upload only. Okay, it's about 1 gigabit, not too fast, disappointing already. Then test the download. Yeah, same speed, 1 gigabit. Then switch to bidirection. Okay, the same symptom appears again. Very bad speed in one direction. I don't think it's due to the cable quality or the Windows machine's issue. It seems there's some limitation in the part for this access point. Even if all the 3 parts for the AP share the same bandwidth, it cannot explain this bad performance. So if you have a similar experience for this part or you have any insights, please let me know. Okay, now the very last topic for this video is about the power consumption and temperature. Because the 4 Wi-Fi clients already stopped the iPerf3 testing, let me resume them. Now I have 5 clients crazily testing the throughput by using both Wi-Fi and Ethernet part. And for this PoE out part, I also plug in a small switch. Let me see what's the current power consumption for this access point. For this part, I can see the power consumption is 12.24 watt. When it comes to temperature, both the front surface and the back are very hot, but the front is relatively cooler. You can see the highest spot has about 138 degrees Fahrenheit. The back is so hot that I don't even want to touch it. You can see the highest part has about 148 degrees Fahrenheit. Okay, this is the end of the video. Thanks for watching.